Hello, this is Miss Nichols. This video is on a super critical skill that really will help you in all of your future science classes, as well as being something that I actually use almost every single day, and it's something called unit conversion. The essential question is, how do I change the units of a variable without changing the kind of amount of something that I have, without violating any conservation principles? So let's start with a real world problem. Let's just say the world is open to travel again sometime in 2021 and we happen to be in Japan somewhere. We've got a plane to catch in Tokyo. We look at the sign which says 70 kilometers to Tokyo, but I don't know how big a kilometer is because I'm American and I use miles in my everyday life. So I got to figure out how many miles away Tokyo is so that I can figure out how long it's going to take me to get to the airport. I realized that in the real world, you guys would probably use technology to solve this problem. You'd pull out your phone, you'd pull up a map, you'd say, how far away is Tokyo? Or you'd pull up Google and you'd say, Google, how many miles is 70 kilometers? And it would convert that for you right away. But I'm going to ask you to bear with me and learn how to do this the long, hard way. And the reason is because, believe it or not, there's actually questions Google can't answer that you can answer with this skill. Really, really important, useful questions for your life. So we're going to learn this skill because A, you're going to use it in chemistry, B, you're going to use it in life, and C, it can actually solve problems that Google cannot, and that makes it a really powerful thing. Okay, so the solution to this problem is a mathematical solution, and the solution is multiplying by 1. I know that doesn't sound like much of a solution, but multiplying things by 1 is actually a really, really powerful tool. And the reason why it's so powerful is because when you multiply something by 1, its value doesn't change, right? We don't want the distance to Tokyo to be changed when we do this, whatever we're going to do to it. We want it to be the same conserved distance. We just want to be able to view it from a different lens, from a different unit, without changing the amount of the thing. And that's what multiplying things by 1 does. So we're going to go back a few steps and talk about multiplying by 1. Multiplying anything by 1 does not change its value. For example, 3 times 1 is 3, right? We didn't change the amount of the original object. You can do this with variables in addition to doing it with numbers. So if I have a variable y and I multiply it by 1, we still have y. Or you could do it by an object. If I have an apple times 1 apple, then I still have 1 apple. So I haven't changed the value of things when I multiply them by 1. Now, the cool thing in physics is there's actually lots of different ways to write a 1, right? We wrote it above just with the number 1, but there's lots of things that are equal to 1 in the world of math and physics. For example, the fraction 5 over 5 is also equal to 1. Now, fractions equal to 1 are particularly interesting because anytime you have something on the top of a fraction and something that's equal to it on the bottom of the fraction, even if they don't look quite the same, we're still going to have 1. So, right, 2 plus 1 over 3, those don't look identical, but they're still equal in value, and therefore dividing 2 plus 1 divided by 3 still gives you 1. And it's true when we have units on things as well. So, for example, 1 foot doesn't look a lot like the words 12 inches, but we know that those are equivalent to each other. We know that in 1 foot there's 12 inches. And so if 1 foot equals 12 inches, then 1 foot divided by 12 inches is going to be equal to 1. So the second part of the solution is creating something known as a conversion factor. A conversion factor is just one of these fractions that's equal to 1 that contains different units on the numerator, which is the top of the fraction, and the denominator. These are some examples of conversion factors. So 60 seconds over 1 minute, that's a conversion factor because we know that 60 seconds is the same as 1 minute, so dividing them by each other equals 1. Another conversion factor that you might not be as familiar with, 0.45 kilograms, which is equal to 16 ounces, that's also equal to 1. That one's a little tricky because we've got a decimal in one of those values, and you probably didn't know that those things were equal to each other, but you could look that up in Google or other places. And then the one we use in the last slide, which is 1 foot over 12 inches, is also equal to 1 as well. So these are all examples of conversion factors. They're fractions equal to 1 that have a different unit on the top and on the bottom. Whenever you have a fact that you know, an equivalency, or two things that are equal to each other, such as the ones given above, you can always create 2 different conversion factors from any single fact. So if you know, for example, that 1 kilometer equals 3,280 feet, we can make 2 different conversion factors out of this. We can make the one that's 1 kilometer on top of the fraction and 3280 feet on the bottom. And because they're equal to each other, that's equal to 1. Or I can flip-flop them and make a second conversion factor where I have 3280 on the top and 1 kilometer on the bottom. As long as you put the units on there, it's still going to be equal to 1. If I have a second fact, 5280 feet equals 1 mile, again, I can make 2 conversion factors out of that. 5280 feet over 1 mile, which is equal to 1, or 1 mile over 5280 feet, which is also equal to 1. So how do we use these conversion facts and conversion factors to actually convert from one unit to the other? Well, the first thing you would do is you're going to want to write down what do you know and what do you want to know. In the problem that I laid out in Tokyo earlier, the thing we know is 70 kilometers. The thing I want is how many miles that is. The second step is to come up with some kind of plan. Now, each step in your plan, you need to know a fact that connects the units between one step to the next. So in this case, I would have 2 steps to my plan. I knew this fact about kilometers and feet. So my first step is going to be converting kilometers into feet. And my second step is, once I know feet, I'm going to convert feet into miles because I have another fact that lets me go from feet into miles. So I kind of have this plan, this path to get from kilometers all the way to miles. In this case, I have to stop at feet along the way. So I have a 2-step plan. Each of these facts can be turned into a conversion factor. Each of them can be turned into 2 conversion factors. But the tricky thing is that you're trying to choose the correct conversion factor. There's 2 choices for each one, and you want to choose the one that lets you cancel certain units from the values that you know and turn them into the units of the values you want to know. So for this problem, for example, I start with 70 kilometers. That's the same as saying 7 kilometers over 1. We could write it as a fraction if you wanted to. It sort of doesn't look like a fraction, but you could make it into 1 just so that it's really clear to you that that 70 kilometers is on the numerator or the top of the fraction. So I'm going to multiply it by 1, but I'm going to choose a fancy value of 1. I'm going to choose one made out of the conversion factors that come from those facts above. So the first thing I need to convert to is from kilometers into feet. That's my first step. So I'm going to make a conversion factor out of my fact about kilometers to feet. And there's 2 choices, but I'm going to choose the one that puts the kilometers on the bottom of the fraction. And the reason is because in a little bit you'll see that we can cancel out that kilometers on the top by putting a kilometer on the bottom. So this is the conversion factor I'm going to choose, 3280 feet over 1 kilometer. The next thing I'm going to do is my second step, which is convert feet into miles. And again, I got to think about which of my 2 conversion facts is going to be the one that's going to let me cancel out one of the units that I have and turn it into something else. So at this point, I have this feet here up on the top, right here, and I want to cancel that out. So I'm going to choose the conversion fact that has a feet on the bottom to cancel out my feet that's on the top. And you'll see in a minute, we'll go through this, but what we're left with is just this units right here, which is miles. And that's the goal, is to end up with miles. So we know that we've basically done it. So once you've done that, once you've figured out which conversion facts to use, you can do this commutative property of multiplication, which you probably learned about at some point, which means you can sort of rearrange the values and the units so that we have all the values at the front and all the units at the back. So we have this big math problem that looks like multiplying together all the things on the top of the fraction, dividing by all the things on the bottom of the fraction. So we have 70, which is right here, right, times 3280 times 1, right? That's what we have on the top of our fraction. And on the bottom, I have a 1 times 5280. Those are my numbers that are on the bottom of the fraction. And then over on my unit side, all my units on the top, kilometers, feet, and miles. And then at the bottom, I just have kilometers and feet. Before I actually plug this into my calculator, I like to go and cross out what units are going to cancel. We see a kilometer on the top and on the bottom, so those are going to cancel. I see a feet on the top and the bottom, those are going to cancel. And I see that I'm left with just a plain old mile, and that's what I was looking for. So that's how I know I'm kind of on the right track here. The last step is the simplify step, which is where we actually plug this stuff into my calculator. And so when you do that, right, when you plug in 70 times 3280 times 1 divided by 1 times 5280, you end up with 43. And when you cancel out all these guys, as we've done several times here, we're left with the units of miles, and that's the units for your answer. So this is how to find out how far away Tokyo is without plugging it into Google in, 8 minutes longer than it would have taken you with technology. Quick little summary, revisit the essential question, how do I change the units of a variable? I know that this was a lot, and there will be some easier practice problems with some quickly, walk through hint solutions to practice on tomorrow. But this is a really important skill that you'll be using the rest of this class and in chemistry next year. So it's worth your time to think about it, to analyze it, to understand it, and to ask for help if you need help. All right, so go ahead and revisit the essential question. Thanks for watching.